start with today, we're going to go back to a bit more of that, the different types of functions you have to deal with. And so what I have here is I have pairs of functions. So there's quite a lot on the screen. And what you need to do for me is you need to say, in fact, I'm going to make this instead of A, B, C, and so on, I'm going to make it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just easier to do this way. And what I want you to do is I want you to go through and see if you recognize what function is what. So, for example, in this first one, I would say 1 in the chat, and then I'm going to go STR for straight line, and I'm going to go PAR for parabola. And so those are the two types of functions that are relevant for number 1. Just to start with today, I want you to go through, well, let's do the first 5 first. So I want you to do 2, 3, 4, and 5, and I want you to name the pairs of functions that are relevant in each question. Okay. And then hi, Puleng, and hi, Kaylee. Welcome to class. Yeah, so to start off today, we just sort of like, we're spotting functions in the wild. What function do you think, what functions are in number 2, 3, 4, and 5? And you pop them in the chat. We're doing these ones. So, Alishana, Artila, I see you, your comment. What topics did you find most difficult in paper 1? I'm curious to know what topics, if you've got a moment while you're doing these questions. What topics did you find tricky? So that would be a straight line, and that would be a hyperbola for number 2. Yeah, don't worry too much, guys, before we let the fear spread too far. Like, you can only do what you're going to do, and sometimes your impression of the exam can be different to what comes out when it's marked. So I have had experiences with students like that before. So before you, see what happens. You do your best. Once you've done your best, that's all you can do. I know it's easy to say that, but yeah. So number patterns, people are saying number patterns was a bit hard. So remember that there is content on number patterns that you can watch on prior recordings for those who are feeling like that they need to top up their number pattern knowledge. Okay, what about, what is the answers for 3, 4, and 5 going to be? So number 3 looks like a straight line and a parabola. And in fact, you know what? If you want, you could just use one letter. So instead of having SP, the S and thing, just go S/P for straight line and then parabola. It'll make it quicker for us to do that. So you've got 2 more, 4 and 5. Oh, so Bianca, you're talking about word problems, but remember, that's just one question. So one question in an exam is not gonna, Okay, Oratile said past video on functions were spot on. Okay, cool. Yeah. Also, exams sometimes have different things in them. So, what I do is I choose the ones that are most probable to come up in the limited time that I have. Okay. All right. So we're going to get back onto the questions here. So for number 4, I would say a straight line and a hyperbola. So I'm just saying S and H. And then for number 5, it's going to be a straight line and parabola. Okay, now what I want you to do next is I want you, so we've done 1 to 5, we know how to recognize them. Now, for number 6, and number 7, I want you to find me the intersection points between these two functions. So let's just start with number 6. In fact, let's forget about number 7 for now. I want you to find me the intersection points, if there are any, between these two functions. And what I'd love from the class is to know, what is my first step going to be when I have to find intersection points of two functions? We have, this is a straight line with a positive gradient, so it probably looks something like that. And this is a happy parabola, so it probably looks something like this. And so you're trying to find these two points over here. What should I do first? I'm waiting for some comments from the class. Who wants to put their hand up and tell me what to do, or put it in the chat? I'd love to hear a voice from a student. We covered this briefly in the last lesson, but what is the technique we use to find intersection points? You don't have to answer. I just want to know what process should we use? Buchle has been very generous and said we should equate the equations. I agree, and so does Morgan. Said simultaneous equations. You're both right. And so what we are going to do is we are going to start by equating those two. And now you need to solve that equation for me, and you should either get non-real roots, or you should get two answers that I want you to try and give me. And then we'll talk about how we find the y values, but I'll give you a bit more time. And there is an awesome equation that we can use to work out quadratic equations, or an awesome formula. I don't know, you don't have to use it. If you can factorize, you can just use that. But worst case scenario, if you look at the number here, which is a 1, and then it's a -5 and a -24, that will get you to the answer. Or if I know how to factorize this, maybe I can get my answer this way. So I look at 24 can be broken into 8 and 3. So there's an x and an x, and an 8 and a 3, and it's going to be -8 plus 3. Yes. And then we know that x minus 8 must be 0, or x plus 3 must be 0. So x must be 8, or x must be -3. And if I look at my little scribble drawing, I think this one over here is the -3, and then like this one over here would be the 8. But I want to know, what are the y values that are going to go with each of these x values? Because I need a full intersection point. And so I want you to work out what y values you think would go with those x values. What do you think, Bouclair? What do you think? So, Keisha, this is functions, paper 1. And we're just carrying on today with functions. We're working on how to, at the moment, we're trying to work out the intersection point for number 6. So if I take the formulas at the beginning, s of x is 7x plus 9, or I could write that if I want as y equals 7 times something plus 9, then all I'm going to do is if I do this, so 7 times 8 plus 9, oh, that's quite a big number. Am I making a mess up here? 7x plus 9? No. I'm putting an 8 in, so that's the one way of doing it. And then the other way of doing it is to put in a minus 3. So what are my final answers going to be for the y? That looks like it's going to be quite a big number. 50, what's that? 7 times 8, 56 plus 9, 65. Just check if you get that. And then for this one, unless I've made a mess up, 7 minus 21 plus 9 is going to be minus 12. Does seem rather large, but let's just make sure I haven't made any silly mistakes. So x minus 8, x plus 3, x squared plus 3x minus 8x, that's fine. X is 8 and x is minus 3 is fine. And that's 7x plus 9. Yeah. So that looks good to me. Give me a thumbs up if you agree with me. Give me a thumbs down if you disagree. So this over here should be 8, and this over here should be minus 3. Okay, so that was a little bit of a hard one, and we try to find the intersection points. So now what I want to do is I want to move on to drawing two graphs. So I'm going to focus on number 10. And I want you to sketch, using whatever methods you know about, and I'll give you some guidelines. I want you to sketch these two graphs on the same set of axes. Now, in order to do that, you need to do your working out first, and you need to identify what type of graphs these are. So we're going to work through it together, but yeah, see if you can do the working out. What are the first steps we need to do for working out for this number 10? I think we need to find the intercepts, and we need to find any axis of symmetry and turning points and those things. So I'm going to give you some time to work out the intercepts and all the other important information. And then when you're done with that, say done in the chat. If you don't know how to do it, well, then I encourage you to ask a question. And yeah, we'll draw the graphs together when we have a moment, when you've had some chance to do some working out. So those are the two graphs we're trying to draw. And that's a straight line. Okay, so I've got my x and y intercept for the straight line. And now I need to work on the parabola. And once you're done working on the parabola, I want you to say done in the chat. Or I'm sure there must be some students who've forgotten some stuff about parabolas. I don't want you to be shy. That's the beauty of the way these lessons work. You just pop it in the chat or you raise your hand. So, oh. I'm going to use, when I taught this earlier, I had what's called a 5-step process or 4-step process. So I'm going to use it. So it's a happy parabola. Number 2, what is the y-intercept? It's going to be 0, 4. So that's probably the first bit where we get a bit stuck. Ooh, something interesting is happening inside the square root bracket. Give me a thumbs up if you get to the stage that I'm getting to now and are thinking, well, that's a little bit fishy. What does it mean? It looks to me like that thing inside the square root, and it has a special name, is going to end up being negative. So what is that thing inside? I'm using what's called the quadratic formula. And according to my calculations, I'm getting minus 28 inside the, yeah. Now, what it means, if you can't solve a quadratic equation, it means that there are no real roots, the graph, it doesn't cut the x-axis. So it doesn't happen that often that this comes up, but if you have a negative inside the square root bracket, this thing inside the square root is called delta. And if delta is negative, it means that the graph doesn't cut the x-axis. So actually, there are no x-intercepts. Now, after you've looked for the x-intercepts, you have to look for one more thing or two more things. What are the last two things I need to find before I draw this graph? What do I still need before I draw this graph? Believe in yourself. Believe. Take a swing at it. Just the act of committing to an answer helps us learn more than just being passive. It's like you have to vote. What are the last two things I need in order to what do you think, Kanisile or Ayanda, Kiara? Who feels like they know what the next two things are that we have to find? Ah, there we go. There we go. So we have to find the axis of symmetry. Orukanisa, you are quite right. And then on the axis of symmetry, we have to find the final turning point. So how do we find the axis of symmetry? We use the formula minus b over 2a when the parabola is in standard form, or we say it's halfway between the two roots, but we don't have roots here. So what is x? So if I use the formula minus b over 2a, it's going to be minus 6 over 2 times 4, which is going to be 6 over 8, which is going to be 3 over 4. And so when I draw the graph, the axis of symmetry is x is 3 over 4. Now, that means that the x value of the turning point is 3 over 4. I now need to find the y value that goes with the turning point. And what I do for this is I go back to the original parabola, which is that function. And all I'm going to do is I'm going to put a 3 over 4 in there. Now, you are going to have to help me, and you are going to have to use your calculators, but help me find what the y value of the turning point is, and then we're going to draw this graph. So if we look at the chat, Ayanda and Morgan are giving us 7 over 4. So where is my, okay, so that means that this value over here is going to be 7 over 4. So now, to finish drawing this graph, what I do is I start by drawing the more difficult graph first. And the more difficult graph is going to be the parabola. So if I look at the turning point, let's just go and find it. So 3/4, 7 over 4 is like 1 3/4. So let's say the turning point is here. We know that this is a happy graph or a happy parabola. So the arms can only reach up like that. And that makes sense that there's no x cut. If that's the turning point, it would never go across that. Now I have to label this value here, which is the y-intercept. But the good news is I've worked it out already. It was 4. And I'm also going to label this in a moment. I just don't want it to interfere with my straight line. So, and then I also need to label it with it's f. It's the function f because of up here. Then if I want to draw the straight line, I also need the intercepts. So I had 0, 7. So 0, 7 would be a bit higher, like up here. And then minus 14, 0. So this is not going to be the perfect scale graph because I should go a little bit further into, it should be a little bit further on here. But basically the point minus 14, 0 is going to be here. And so my straight line is going to look like that. And I'm going to label minus 14 here. And I'm going to label 7 here. Now, if they want you to label full coordinates, you would just add coordinates. And then the other value that I need to label is the turning point, which is going to be 3 over 4, 7 over 4. And yeah, the straight line, you could say, could carry on going. But I haven't, you get the basic idea. And I've labeled that. What was the equation? That was the D. Okay, now I just wanted to take you through one where we drew it from the beginning to the end. Give me a thumbs up if you followed my process for drawing straight lines and parabolas. I would recommend looking at my earlier videos if this process is completely new to you, because I went through this process a lot more slowly, obviously, when we had multiple lessons for it. This is more of a recap. So just give me a thumbs up if you're generally with me. And then I just want to ask, or a happy face and then a downward face if you're not happy, or a meh in the middle face if you're in the middle. Okay, last couple of interpretation questions. We like a bit of interpretation. So I want to know, what is the range of the parabola? So if we look at the parabola is the green graph, it is defined by this formula up here. And we did all the working over here. I want you to write down, what do you think the range of the parabola is, or the function f is its name? I want you to put that in the chat for me. What is the range of this parabola? What do we even have to look at for the range? Do we look at x's? Do we look at y's? That is the question. So Morgan has correctly said that range deals with y. So it's going to be y something. Is it going to be greater than or less than something? It looks to me like the lowest that the green graph gets is, what's this value over here? Now, it's actually going to be 7/4. So is y less than, equal to, greater than, equal to? What's this relationship going to be? I think y has to be bigger, or it has to be equal to 7/4. So if I have to use a different color, the y values that are valid start at this point, and then they just keep going up from there. All right, so that is halfway through today's lesson. And what we did in the first part of today is we recognized functions, and then we looked at calculations with functions, and we looked at how to draw two common types of functions. And so now we have earned a nice break. So please pop your cameras on if they haven't been throughout the whole time, and join me in standing up and just unwinding a bit. Okay, let's start with some deep breaths. Breathe in. Breathe out. Breathe out. Breathe in. Breathe out. Breathe out. Okay, then let's start with a bit of a shake into our arms. Get the blood flow moving. Really flap that arm around. Flap this arm around. Shake your legs around. Shake the other leg around. And then let's start by having our arms out. I'm just going to gently rotate. And as we relax, we're going to move further to the left and further to the right. Okay, then I want you to roll your shoulders back. So 1, 2, 3, 4, 5. Roll your shoulders forward. 1, 2, 3, 4, 5. Then I want you to put your hand behind you like this and stretch your tricep and look out in front of you. Just hold it. That feels good. And then switch to the other arm. Okay, then get those arms nice and loose again. Okay, we haven't done jumping jacks in a while. I know they send the heart rate a bit high, and I know that there's a danger we whack something over. So just look around you, make sure nothing's too close, because you're going to get a bit physical now. And a jumping jack is just this movement, as I'm sure you all know. And let's see if we can make it to 20 or as many as you can manage without falling over. Okay, 3, 2, 1, let's go. Halfway. And yeah, My body feels like it is, ooh, the blood is pumping, the oxygen is pumping, all the good stuff is happening. So while our heart rates calm down, see if you can if you can solve a mass 24 puzzle over there. Your suggestions in the chat. This one's a bit trickier than I'm struggling to do the red one. Oh wait, orokinesa, 8 times 4 is 32. And then minus, so 8 times 4 minus 8 times 1. Oh, there we go. And then there we go. Brooklyn and Lissakanya also got that. So well done. So we got 24, and see if we can get 24 for the blue one. We have a 3, 3, 8, and 2. So Ayanda has said 3 times 8 is 24, which is great, but now I need to use up the 3 and 2. So why not just say divided by 3 minus 2? And so basically what you get is you get that. Yep, Ayanda, I think you have nailed it. And so has Mbali and Zanele, same idea. Awesome. Okay, let me know in the chat, how are you feeling about the second part of the lesson? Are you ready to roll? Are you feeling like meh, out of energy? Are you feeling like I was born for this? Let me know with an emoji in the chat, because I can't see everyone's faces, so I want to get a feel for where you're at as I choose the next question. Okay. So what I think we should do is we should look at a question where they give you a function, and then you have to, a typical exam question is either like this, or they tell you to draw the graph and things like that. So step 1 here, I want you to identify what are the 2 types of functions involved in question 3 here. So step 1, tell me what type of functions are involved in question 3. You can just use the first letter name. Okay, Mbali and Zanele, I agree. Malcolm, I agree. This is a parabola and a straight line. And Morgan, I agree with you too. Okay, now I want to do 3.1.1 and 3.1.2 to start with. And if you're feeling generous, maybe you can give some tips in the chat to those who would struggle getting started with 3.1 and 3.1.2? What are you going to need to do to answer those two questions? Don't be afraid to give tips to your friends. What do they say? Sharing is caring. So A has a particular type of thing, and B is a particular type of thing. And A seems to be related to this function, and B seems to be related to that function. What do we think the answers are? Pop them in the chat. So 0 on YAB. Okay. So I think what Morgan is suggesting is that A is a y-intercept. Oh, can you see they said find both of these are y-intercepts. So we use whatever process we need to find the intercepts here. That makes sense to me. So what are they going to be? Well, if I make x 0 in this one, I should get 3. So A should just be 0, 3. You've got to remember that it's a y-intercept, so there's a 0 in front. And for B, it's going to be, well, I make 0 here. So if I go, the g of 0 is equal to 0 minus 1. Sorry, 0 minus 1, I'm going to get 0 minus 1. Yeah. Okay, what is the length of AB? So now we're asking, how far is it from here to here? So indeed, we are revising functions, which is in paper 1, yes. Yeah, so if this is minus 1 and that is 3, well, then it's 3 to go there and then another 1. So this would be 4 units. Okay, now the next thing we're going to do is find the coordinates of C and D. What's special about C and D? What's special about C and D that could help us? Because it's worth 4 marks. So it's going to be quite a bit of work. What do we have to notice about C and D? So one of them is an intersection point, but actually I think these are, like Mbali and Zanele is indicating, these are x-intercepts. And in order to find the x-intercepts, you need to make y equal to 0. But we have to make sure we choose the right function. Are we going to work with f or are we going to work with g? Which one should I work with to find C and D? Should I work with f or should I work with g? Yeah, so we should work with f because that's what C and D are on. And so you are going to have to solve that equation for me to find me the coordinates of C and D. So we'd either do it like that, or we can use the quadratic formula to help us. So that strikes me that so what is C going to be and what is D going to be? So there's still some work to be done here. My X values are -3 and 1, but what is C going to be? What is D going to be? I need to make a decision, and I need to fill in some extra information here. So I think that I think there must be a mistake in this question. Why do I think there's a mistake in this question? Unless I've made a mistake in my writing down. Why is the drawing not fitting with reality? So C is 3, not -3. Let's have a look. X, yes, that makes sense. So how did I know? So you're right. So what people are saying is that the quadratic equation skips some of that problem there. So maybe for some of you, that would have been a better bet. So I think that the C is a 1 and the D is a 3. And so I know that C will be 1, 0, and D will be 3, 0. So all that happened, and this can happen to you, is that I switched one of the signs around, but we know this x minus 3 must be the same as 0. And then when I bring it across to the other side, it'll be +3. But I like your advice, Ayanda. Okay, thumbs up if that made sense to you, thumbs down if it didn't. And then we are going to skip to question 3.1.5. Noreen, let's go to you. I'll unmute you. What is your question? Can you hear me, Noreen?
Just
Hello?
check your screen. It's going to ask you to unmute.
Yeah. Or maybe that was a mistake in hand. That's fine. Okay, everyone else, let's try and do 3.1.5. And we're pretty close to finishing off for today. So let's see. What is special about E? What did we do earlier in the lesson that can help us? So this actually, Morgan, it's actually not as simultaneous. If we were doing 3.1.4, that's about the intersection point, but this actually is the turning point. And if you remember in the previous exercise, I used a formula to find what's called the axis of symmetry. So it's kind of like, and then I also need to find what that y value is. Now you can use a formula, or parabolas are symmetrical. So it'll be halfway between the two roots if you want the axis of symmetry. So work out point E for me here. So Kanyisile, you're quite right. The turning point is the name of the thing. And the formula I used earlier on was -b over 2a. And so in this graph, it would be -4 over 2 times 1, which would be 4 over 2, which would be 2. And so what that's really saying is that that must be in line with 2. But that makes sense because we know that C was the 1 and this was the 3. So it's halfway between. But the turning point needs a second value. What is that second value? Well, I take the 2 and I put it back into F, or I find the F of 2. And that is going to give me 4 minus 8 plus 3. So that's minus 1. So this is minus 1. So this would be in line with minus 1. Okay, last 2 questions. For what values of x is x squared minus 4x plus 3 greater than x minus 1? Now, the way I want to visualize this for you is I want to give each of the graphs a color. So imagine that x squared minus 4x plus 3, that graph is the parabola. And the parabola is kind of like, if we just focus on that as one color, there it is there. The straight line is x minus 1. I'm going to make that look like that. What this is saying is for what values along the x-axis, so for what values along this line here, the x-axis, is the green one above the blue one? So if I start over here, is the green above the blue at this point in x's life? Yes or no? What do you think? In this part here, is the green graph above the blue graph, or is it below the blue graph? Yeah, so it looks to me over here, the green graph, or the x squared minus 4x plus 3, is above the blue graph, and they want to know for what values of x this happens. So I'm in business. I'm going to leave the pink bit there. Then once I get to this point, they are equal. And then the blue is king. The blue is above the green. And I'm not interested in the x values where the blue is above the green. I want where green is above the blue. So the next time that the green is above the blue will actually be at that point they'll be equal. It'll be this thing over here. Now, because I left out question 3.1.4, we don't know what the x value is here. But all we would do is we would describe the answer as this region up to here, and then we would go from this region over here. So wherever the green is above the blue, that's the x value that I want. Okay, now we know that C was 1, so x would have to be less than 1, or x would be greater than whatever this value is over here. And I don't know what it is at this point. Okay, that was a toughie. And if you're a bit confused, you can rewatch that because it'll make more sense when you rewatch it. Last question for today. For what values of x is f of x, which was the green one, less than 0? Now, what this means is it's saying for what values of x is the green one below the x-axis? So when is the green graph, or f of x, less than 0? When is it below the x-axis? So to me, it looks like this is the time where it's below the x-axis, and I have to describe this region here. Who can write that down for me as an inequality? So x must be, C was 1, so x must be greater than 1, and then D was 3, and so the answer would be x is greater than 1 and less than 3. The moment x is bigger than that, it won't be below the x-axis anymore. All right, so guys and girls, that is today's lesson.